Alright, so now that we've discussed the periodic table, we've discussed what ions are, we've discussed what cations and anions are specifically, we've discussed chemical reactions, bonds, and we've discussed polyatomic ions. So one thing you had to know was on the left side of the periodic table, let me put this periodic table here, you have left side, quote, quote, because left side is kind of from here over. You have metals that turn into cations. Let me show you. Cation. Okay, but for real, let's get back to chemistry. That was a cat. And you have these metals that turn into cations and these nonmetals that turn into anions. When they lose their electrons, cations, when they gain their electrons, anions. So let's go through a few practice problems. So here I've got NH4Cl. So one of the things I told you guys was that you have to know your polyatomic ions. The only one that is positive is NH4, which is called ammonium. Okay? So you just have to know that. And then NH4 is bonded with Cl. Cl is here, right? And I told you that these are your nonmetals. I'm going to denote that as Nm. And these are your metals. So this is a cation. This is a nonmetal that will gain this positive charge, or I'm sorry, that will gain alright, so this is NH4 with a positive charge, and Cl, it gains electrons, so it has a minus charge because it gains negativity. So sometimes I just like to write the positive and negative signs above the ionic compound formula, molecular formula. So I would write plus and minus, right? Because that plus is with that and that minus is with that. So you'll notice that this 1 plus and this 1 minus, if you have 1 plus, if you have positive 1 plus negative 1, you get 0, right? Math. So let's put brackets around it so that I can say that this has a combined neutral charge of 0. Because it says plus 1 and it says minus 1. So the whole thing, when bonded together, is 0. So that's ionic compounds in a nutshell. They are a cation that has bonded with an anion to make a neutral ionic compound. The cation is wrote on the left, the anion is wrote on the right, because typically metals are on the left and nonmetals are on the right. So we just call this ammonium chloride. So what you need to know is that the left side, the thing that functions as a cation, is just whatever its name is. Ammonium, sodium, lithium, magnesium, whatever its name is. But then this, typically it's chlorine. We just take the end of it and turn that ene into ide. So it all just gets turned into ide. So it's called ammonium chloride. Next on the list, I have this. So there's a few things here. Iron, it's in the middle part of your periodic table. It is here. This is where iron is. It's in the middle part, and this is your transition metals, right? It's still metals. Now I told you guys that transition metals are just a little quirky. The reason they're quirky is because you have to determine their positive charge depending on the negative charge that they're bonded with. So this whole thing has a neutral charge of 0, right? This is the cation part. It's the part that's a metal, right? This part, in parentheses, is a polyatomic ion. It's on the right side of this formula, and if you memorize your polyatomics, you know that this functions as a polyatomic anion. So what is its charge? Its charge is 1 minus, right? So 1 NO3 is 1 minus. If we were to draw this out, we would have 1 iron, because there's an invisible 1 subscript there. We don't have to write the 1s. There's NO3, and this subscript right here, outside of the parentheses, tells me that there are 3 nitrates. So if we were to draw it, it would look like this. So this is 1 minus, this is 1 minus, and this is 1 minus. So I have 3 of them, denoted by this 3 subscript. And so 3 1 minuses, let's do a little math, equals 3 minus. So this 1 atom needs to negate that. In order to do that, this 1 atom has to have a total charge of 3 plus. So these have 1 minus, and this 1 iron atom has a charge of 3 plus. So most metals, you can figure out the charge based on what column it's in. Things in 1A have a charge of 1 plus, things in 2A have a charge of 2 plus, things in 3A, besides boron, which is a metalloid, have a charge of 3 plus. The metals that are transition metals depend on the charge of the nonmetal. So we've just figured out the charge of this iron, this particular iron, this particular compound. So transition metals you have to write a little bit differently. You have to include the charge and the name. And you do that by writing it as a Roman numeral in parentheses. So I write it like that. Iron, 3, nitrate. Because this iron has a charge of 3 plus. Next on the list, I have TiBr3. Well, Br is another nonmetal. It's in the 7A column. It's here. So things in 7A have a charge of 1 minus. 6A, 2 minus, 5A, 3 minus, 1A, 1 plus, 2A, 2 plus, transition metals, and then 3A is 3 plus. Right? Well, titanium is a transition metal. We can go ahead and write the name as this, titanium bromide. Remember, the anion always turns into ide. But we have to figure out the charge of titanium. Well, bromine is in the 7A column with a 1 minus charge. but this subscript here denotes that it has 3 bromine atoms. So again, if we were to draw that, it's really just the same concept we just did. 3 negative charges totals to 3 minus. So this one titanium atom must have a positive charge of 3 plus to make the difference here, so that this is a neutral compound. So that's how we fill that in. We have more transition metals coming up. Next is copper phosphide. So what you see here is that there are 3 coppers and 1 phosphorus. So this is phosphorus and our 3 coppers. We can go ahead and name it as copper. We need to figure out the charge. This is called phosphorus, but it is a nonmetal and it is a anion. So we turn that to phosphide. Now phosphorus is in the 5A column, so it has a charge. Let me pull this down. Phosphorus is in the 5A column, so it has a charge of 3 minus. So this one here is 3 minus. And this has to be a neutral compound, right? So what charge can we give to 1 copper atom to negate the 3 minus charge? So if this is 3 minus, and this has to equal 3 plus in total, what charge do we give these single atoms? Well, we give it a 1 minus charge, so because there's 3 of them, or 1 plus. So 1 plus, plus 1 plus, plus 1 plus equals 3 plus. So 3 plus and 3 minus gives a neutral ionic compound. So the charge we write here is 1, Roman numeral 1. So we have copper 1 phosphide. Next up, we have SnSe2. So this is tin, and this is selenium. Tin is a metal that is in the 4A column. Notice I didn't put anything. Sometimes Alright, so now I have Sn and Se2. Sn bonded to Se2. So this is tin and this is selenium. Tin falls in the 4A group, and it's below the metalloids. It is a metal, and selenium is a nonmetal. Selenium is here. Even though this is not a transition metal, things in 4A column can kind of differ with their charges. Carbon can be plus or minus 4. Most of the time it's plus 4. And then the metals, they can sometimes differ too. So it's a good idea to kind of treat it like the transition metals. You can always figure something's charge out by taking this approach. So selenium is in the 6A column, so it has a charge of 2 minus. And there are 2 of those. So it's 2 minus plus 2 minus. You know, think of like a number line where you have 0 and then minus and plus. So 2 minus plus 2 minus equals 4 minus, right? So this charge is 4 minus. Now remember, this is an ionic compound. They're bonded together, and ionic compounds have a neutral charge. And there's only one tin atom. So that one tin atom must equal 4 minus. Therefore, must equal 4 plus. Therefore, that one tin atom has a charge of 4 plus. So just like I said, metals which have positive charges that are in the 4A column have a charge of 4 plus. So you write that as tin 4 selenium, or tin 4 selenide. It's weird. Or you could just say tin selenide. Next on the list we have GaAs, and this is gallium arsenic. Ga is right here. It is a metal. It's in the 3 plus column, 3A. And arsenic is a metalloid, and it's in the 5A column right here. Now I'll go ahead and tell you this worksheet, this particular worksheet that I'm using, they often treat metalloids like nonmetals, so you should do the same. So gallium, it's on the left side. It functions as a metal, which functions as a cation. And this arsenic, it's functioning as a anion. Arsenic has a charge of 3 minus because it's in the 5A column, and gallium in the 3A column has a charge of 3 plus. So they balance, and you're done. You just write the name. Gallium arsenide. Next on the list we have PbSO4 2 minus, or 2. You notice that the SO4, the sulfate, is in parentheses because there are 2 of them. So if you wanted to draw it out, it would look like Pb atom, SO4, SO4. Now, SO4 is one of your polyatomic anions that you have to know, and you should know that this has a charge of 2 minus and 2 minus. So 2 of them would be 4 minus. So this one lead must have a total charge of 4 plus. So you write that as lead sulfate. Notice that there's a difference between sulfate, sulfite, and sulfide 4. So lead sulfate, lead 4 sulfate. Next up we have BeHCO3 2. You know that Be is beryllium, however you want to pronounce it. And you should know that this is bicarbonate, and there's 2 of them. And you should also know that bicarbonate has a charge of 1 minus. So if we were to draw this again, we would have Be, which is in the 2nd column, 2A. You know that because it's in the 2nd column, it has a charge of 2 plus as a cation. And you have 2 HCO3s. And you know that one of them each has a charge of 1 minus. So you see how this 1 minus plus 1 minus equals 2 minus, and how this 1 beryllium has 2 plus. And you see how those 2 would combine to equal 0 and give you a neutral ionic compound. So this is not a transition metal, so you don't need the Roman numerals, so you would simply write the name out. Beryllium bicarbonate. Next you have Mn2 SO3 3. So this is a subscript for manganese, and this is a subscript for sulfite. So manganese is another transition metal, so you have to figure out what its charge is based on the charge of this. So there are 3 sulfites, and you know that sulfite has a charge of 2 minus, and there's 3 of them. So I really have 2, 4, 6 minus, and there's 2 manganeses. So if I wanted to draw this out, I would have 2 manganeses, and it might be something like this. Oops. This is not really how it would bond. This is just to give you a visual. So 2 minus, 2 minus, 2 minus. So if this is 6 minus, what positive charge does each of these manganeses, and there's 2 of them, have to have? Well, what is 6 divided by 2? You get 3. So each one has to have a 3 plus charge. So you can then write it out as manganese 3 sulfite. Does that make sense? Then we have AlCN. This is one I left off the list, but it is also good to know that Cn is cyanide. And if I remember correctly, cyanide has a charge of 1 minus. Yep, 1 minus. And aluminum is a transition metal, so you have to figure out its charge based on the anion. So you know this is an ionic compound, has a neutral charge of 0. There are 3 cyanides, therefore there's a total charge of 3 minus. So what does this one aluminum have to have a positive charge of? It has to have a positive charge of 3 plus, right? So it can balance out and have a neutral compound charge of 0. So you would write it as aluminum, Roman numeral 3, cyanide. Alright. So let's just do a couple problems in which you would have the words and have to figure out the formula. One of them is chromium 6 phosphate. So if you were given this, how would you figure out what to write as the molecular formula? Well, you know you gotta have chromium and phosphate. What is phosphate? Phosphate is PO4 and the charge is 3 minus. But these are bonded, so you don't write the charge because it balances out. So you write chromium phosphate, right? Well, if you know that phosphate, just one of them has a charge of 3 minus, and this told you, let me just write this above here, this told you that one chromium has a charge of 6 plus, what can you do to make these equal? What can you do to phosphate to get 6 minus? Have 2 of them. So then you would have 2 times 3 minus, which would equal 6 minus, right? And that one chromium has a charge of 6 plus. So 6 plus 6 minus equals 0. And that's an ionic compound. They're bonded together. They have a neutral charge, so that works. And there's your answer. Cr, parentheses, PO4, and parentheses 2. Alright, so next on the list is vanadium 4 carbonate. So again, just start by writing down what you know. You can look on the periodic table and know that vanadium is V. You should know that carbonate is CO3. You should also know that CO3 is a polyatomic anion with a charge of 2 minus. And this told you, so I'll write the 2 minus above here. And this told you that the vanadium charge, just one vanadium atom, has a charge of 4 plus. So what can you do to make these work out? Well, you do kind of the same thing. And you have 2 carbonate atoms, so that you have 2 minus plus 2 minus equals 4 minus. And that one vanadium is 4 plus, so that works. So that's how you would write it right there. Next you have tin 2 nitrite. Now tin again is in the 4A column, but like I said, the 4A column is kind of weird. So just go off what you know. Tin is wrote as SN. Nitrite you should know is NO3 1 minus. So you just write NO3. And this told you that one atom of tin has 2 plus, and you know that nitrite has 1 minus, so you need 2 of them to work it out so that you have a neutral compound. And that's how you would write it. Then you have cobalt 3 oxide. You know that cobalt, also a transition metal, is written as CO. And we talked about oxide. I'm sorry, that was peroxide, but oxide is just oxygen, right? And then you just turn this into ide, right? And this told you here that this one cobalt atom has a charge of 3 plus. Oxygen is in the 6A column, and you know that one of them has a charge of 2 minus. So what can you do to make those equal? You could do the crossover method, in which you put 2 here for 2 cobalts and 3 here for 3 oxygens. But what that's really saying is that you have 2 cobalts that have each one a 3 plus charge, so you have 6 plus, and you have 3 oxygens, each of which have a 2 minus charge, and that's 6 minus. So they balance out, so you have a neutral compound. And so that's how you would write it. I'm going to go down to lithium iodide. So lithium is in the 1A column, therefore you know it has a charge of 1 plus. And iodide is in the 7A column, and you know that has a charge of 1 minus. So they balance out. This is just typical rudimentary. You know that it's in column 1, you know it's in column 7A, you know it has 1 plus, you know it has 1 minus. It's balanced in the sense of charges, so you simply write these symbols, lithium iodide, and that's how you do it. So we have finished talking about ionic compounds. We've done several problems on ionic compounds. Next, I have a worksheet involving a mixture of covalent compounds and ionic compounds. So the big deal there is that you should know that ionic is metal plus non-metal, you know, like cation plus anion. positive and negative. Then you should know covalent is nonmetal plus nonmetal. If you know these two things, it's going to be easy as pie. So the first thing on the list is sodium 2CO3. You have to figure out first if these are metals or nonmetals. Sodium, it's in the 1 plus column, so it's a metal. I'm going to write N below it. CO3, that's one of your polyatomic anions. I said anion, so we'll just write nonmetal so that you can remember metal plus nonmetal. So because we have that, we know it's ionic. So we have to know how to name it. Well, carbonate has a charge of 2 minus, just one of them. And sodium, just one sodium atom has a charge of 1 plus. But there's 2 of them, so that equals 2 plus. So 2 plus and 2 minus, balanced charges. We simply name it sodium carbonate. Next on the list we have P2O5. Phosphorus is a nonmetal. Oxygen is a nonmetal. Therefore we have a covalent compound. So let me just backtrack real quick. With the ionic compounds, you don't have to write disodium carbonate or even disodium tricarbonate. You don't have to write the di or tri because we know the charges. We memorize the polyatomic charges and we know the charges of things in 1A, 2A, 3A, 4A, 5A, and 6A, and 7A. We know those charges, so we don't have to put the suffix or the prefix. With covalent compounds, it's nonmetal and nonmetal, there's no charges involved, so we do have to differentiate with prefixes. So here I'm going to write diphosphorus. Notice that the first atom listed is on the leftmost side, and this is on the rightmost side, left, right. And notice that the leftmost atom is just its name with how many atoms it has. Diphosphorus. And then we write this prefix for 5, pent, for like pentagon. And then oxygen, we write pentoxide. A common mistake here is to write pentaoxide. I guess it's because it's 2 vowels side by side. You don't need that A. You just need pentoxide. And so notice that the rightmost atom listed becomes "-ide". Next on this list is NH3. You just have to know that that is called ammonia. Then we have FeSO4. This is a polyatomic anion, and you should know that it has a charge of 2 minus. There's 1 iron, so that 1 iron has to have a charge of 2 plus. So we write it as iron 2 sulfate. Next is SiO2. Earlier in the video I told you that this particular worksheet I'm using is treating the metalloids as nonmetals. So let's just say nonmetal plus nonmetal. That's a covalent compound. And so there's just 1 silicon. So you write it as silicon dioxide. One thing to notice is that we didn't put a prefix here. We don't put mono on the leftmost atom, but if there was 1 oxygen, we would put mono on the rightmost atom. Does that make sense? I'll show you an example involving C and O. That's carbon and oxygen. They're covalently bonded because this is a nonmetal and a nonmetal. And what would we call this? I'll give you a hint. It comes out of your car exhaust. So we would call that carbon monoxide. Notice how there's one silicon, there's one carbon. I simply just wrote the name, no suffix necessary. There's two oxygens, so I wrote di, and then I turned the oxygen into oxide. Here I also turned oxygen into oxide, but I also added monoxide because there's one oxygen. So that we do not put mono on the leftmost atom, but we do put mono, if necessary, on the rightmost atom. Let's continue with the examples. We have GaCl3. Gallium is a metal. It's in the 3+ column. Cl is in the 7A column, and it is a nonmetal. So metal plus nonmetal is an ionic compound. There are 3 chlorines here. You know that one chlorine is 1 minus. So you have 1 minus, 1 minus, 1 minus. So that's 3 minus in total. And gallium is in the 3+ column, and you know that has, or gallium is in the 3A column, so you know that has a 3+ charge. So it's already balanced, all that good stuff. So we simply call that gallium chloride. Just the name of this atom, and then this atom's name with "ide." No prefix is needed because it's an ionic compound. And no Roman numerals are needed because this is not a transition metal. Next up we have COBr2. Now cobalt is a transition metal, so we will need Roman numerals. Br is in the 7A column, and it has a charge of 1 minus. One bromine has a charge of 1 minus. There's a subscript here for 2 of them, so we have a total negative charge of 2 minus. And there's 1 cobalt, so that 1 cobalt has to equal 2+. So we write it as cobalt, Roman numeral 2, for the 2+ charge, bromide. So same thing here, we write just the name of the atom for the cation, and we turn the anion's name into "ide" at the end. The difference here is with the Roman numeral. This is in a set column that we do know the charge of all the time. 1A, 2A, 3A, 5A, 6A, 7A. We always know what those charges are. But cobalt is a transition metal, so its charge depends on the charge of the anion it's bonded with, or the charge of the polyatomic anion it's bonded with. So we have to write that in Roman numerals. You see the difference here? Next is B2H4. Boron is a metalloid. I told you this worksheet was treating metalloids as nonmetals, so I'll write that. And H4, I told you hydrogen can function as a metal or nonmetal. I also told you, or not really a metal or nonmetal, but it can function as a cation or an anion. It can lose its electron and become a cation, loses in negativity, makes it positive cation, or it can gain another electron and become an anion. I also told you that cations are typically wrote on the left, or they're always wrote on the left, and then anions are wrote on the right. So this is written on the right, so it's kind of functioning as a nonmetal. I'm going to put it in quotations. I'll put this in quotations too, since it's actually a metalloid. And so you have nonmetal plus nonmetal equals covalent. Alright, so because it's covalent, we do have to write the prefixes. So we call this one diboron tetra, think tetris for 4, tetrahydride. So notice the hydrogen turned into hydride. And the 4 comes from the subscript 4. and the di comes from the subscript 2, and this is just written as boron. Alright, P4. What do we call that? We simply call that phosphorus. It's just elemental phosphorus. It just has 4 phosphoruses that are bonded together. They're sharing electrons, covalent bond. Now remember, there are 6 diatomic molecules you have to know, like gaseous, oxygen, and nitrogen. And those are written as O2 and N2, and then there's 4 others. Let's keep going with a few more practices, and then we'll wrap up the video. Next, if you're given these questions in word form and you have to write them in molecular form, I'll write 3 at a time here. So if you were given dinitrogen trioxide, nitrogen, and lithium acetate, what would you write the molecular formula as? Well, I just discussed this one. You would just write N2, right? Gaseous nitrogen. It's one of the diatomic molecules you're required to know, and I know that's on Dr. Sood's slideshow, so check that out. So let's start with this one, dinitrogen trioxide. Well, it's got nitrogen and oxygen in it. This is a nonmetal, this is a nonmetal, so this is a covalent compound, and that's why it has the prefixes. So you simply write N and O for nitrogen and oxygen. They're covalently bonded, so we write them together. Di means 2, and tri means 3. So that's how you would write that one. And then you have lithium acetate. Acetate, that's one of the polyatomic anions you have to know. And you know that acetate is CH3 Cu, right? We talked about that. And notice that it has a negative charge, a 1- charge. Lithium is in the 1A column and has a charge of 1+. 1+, 1-. It's good to go. You simply write lithium CH3COO. This is the polyatomic anion you're required to memorize. That's as an anion. When an anion bonds with a cation, you don't have to write that negative charge because together they balance their charges out and have a neutral compound. Alright, so some more problems would be like phosphorus trifluoride, vanadium oxide, aluminum hydroxide. Alright, so for phosphorus trifluoride, phosphorus, that is a nonmetal. It's in column 5A. And fluorine, notice that the fluorine turned into fluoride because it's on the rightmost. Fluorine is also a nonmetal in column 7A. So nonmetal plus nonmetal gives you a covalent compound. So that's why you have the prefixes. There's no prefix here, so it's just 1 phosphorus, and then there's 3 fluorine for the tri. And that's how you write that. Oh, I missed one little thing here. I'm supposed to write the Roman numeral there. So vanadium 5 oxide. Vanadium, it's a transition metal, so its charge depends on the oxygen. But they tell you here in this Roman numeral that one vanadium atom has a charge of 5+. Let's go ahead and write down what the molecular formula would look like without the subscripts. Alright, so we know that this has a charge of 5+, just one of them. And we know that oxygen has a charge of 2- because it's in the 6A column. So what can we do to get these to balance charges out to have a neutral compound? This is another instance where you can do the crossover method, where you just write 2 and 5. And the reason you can do that is because 2 vanadiums each have a charge of 5 plus, which would equal 10 plus. And then 5 oxygens, each of which have a charge of 2 minus, would be 10 minus. So 10 plus and 10 minus. It's good to go. Aluminum hydroxide. Hydroxide is another polyatomic anion you have to know. It's this, OH minus. See the 1 minus sign? There's only one of them, right? Or I'm sorry, there's no charge written here. And aluminum is another never mind. Aluminum is in the 3A column, and so you know it has a charge of 3 plus. But hydroxide has a charge of 1 minus. So how many hydroxides do you need to give you 3 minus? Well, you need 3 of them, right? So that might look like this. Three plus, 1 minus, 1 minus, 1 minus. See how that works? So you write aluminum hydroxide. See how I put that hydroxide in parentheses? Just a couple more problems. We have zinc sulfide. Notice it's ide, not ite. Silicon tetrafluoride. Silver phosphate. So zinc is another one of your transition metals, so its charge depends on the anion it's bonded with. Sulfur is in the 6A column, so you know it has a charge of 2 minus. So in order for this to balance, and there's no Roman numeral written here, so you know that this has a charge of 2 plus, because there's no Roman numeral written here. So this would simply be zinc sulfur. 2 plus, 2 minus. It works. And then silicon tetrafluoride. Silicon is a nonmetal. Fluorine is a nonmetal. So you have a covalent compound, which is when you have the prefixes. There's no prefix here, so you simply write silicon fluoride. There's tetra, so you write 4. Silver phosphate. Silver is written as Ag, and phosphate you should know is PO4 3 minus. It's a polyatomic anion, right? So you write PO4. Let me write it a little closer together. PO4. Alright, so silver is a transition metal, right? So its charge depends on this. Well, phosphate has a charge of 3 minus. So this must have a charge of 3 plus. There's no Roman numeral written there. There's no Roman numeral written there, so you can assume that it's 1, and this is 3 minus, so you need 3 of these 1s to equal 3 plus. So you have to write Ag3PO4. And that wraps up the naming of ionic compounds and covalent compounds. I know this video was kind of lengthy, but if you watched it in its entirety, I hope it was very helpful, and thank you for watching.